Okay, we are here to try to find out if these are indeed meteorites. They have a lot of evidence. There's a lot of evidence that they are meteorites. They're very smooth on the outside, and they have these holes. A meteorite could look that way. Okay, so what we did was we looked around in our lab, and somebody had picked up another sample of that. It was a very large sample. We could see it better, and it does have all these little holes in there, just like it came down from space and got heated up in the atmosphere. And somebody in our lab has broken off a chunk so we can see what it is like on the inside. And what we see is there's a very fine coating that's black on the outside. Inside is different. Now the black coating could be from a meteorite. Again, if a rock comes in from space, gets heated up a great deal, the outside could get baked. So you'd have a very thin layer that's baked, that's dark. Now when I saw the inside, it made me think of limestone. I'm here in Utah, but I'm from upstate New York, and we have a lot of limestone, and I've seen this many places, so that looks just like limestone to me. And we have a special test for limestone, and we're going to take a pause and come back with that test. Limestone is to add acid and see if it bubbles. Now we're going to show you that reaction first. We have a chemical which is like limestone, or is like calcite is actually the name of the mineral, and the name of the chemical is calcium carbonate. So the name of the chemical we're looking for is calcium carbonate. If there's calcium carbonate, that means it's limestone, as I'm guessing. Now, when I add this acid to this chemical, we should get bubbles. Now, this is a positive test for carbonate. And there's our positive test for carbonate. So that's what we're looking for to see if this is limestone, which is what I think it is. So we get this out of the way, and we get the other one here. Okay, so we're going to pour this over here and look for the same bubbling reaction. If we get those bubbles, we know this is limestone, like what we have in upstate New York. Very common rock. Looking for bubbles, looking for bubbles. And here, oh, there's no bubbles. So I was wrong. My hypothesis was it was limestone because it looked like limestone. And now I know I was wrong. Okay, and we're going to pause a second to let me clean this up and then go to another test. So we've now shown that this is not limestone, and we have to look at other possibilities. Okay, now at this point I did a little bit of research, and I found that rocks like this are found in the desert around here. And what they are normal rocks around here with something called desert varnish around it. And another thing is this rock is pretty heavy. So that's something we have to keep in mind. It's pretty heavy, pretty dense. Now this coating is known as desert varnish. So in the desert, when a rock sits around for a while, it gets dark like this. A dark deposit is formed on there. We're not exactly sure what causes that, but many scientists believe what happens is water will land on a rock, and then it will spread out inside the rock, and as it goes, it's going to be dissolving various chemicals. And then the chemicals and the water will then eventually get to the outer surface. So the water is inside, it flows around, dissolves minerals. When the water gets to the surface, the water will evaporate. It will disappear, but it will leave behind a deposit of a mineral. In this case, it would be something containing manganese. So this is probably desert varnish, and this substance is probably something with manganese, and it's very common here in this desert area. Scientists think that there may be bacteria, maybe algae, something else helping this process along, but that's probably what this is. Now, this rock happens to be very heavy. Okay, so heavy rocks often are from volcanoes. And I looked at some maps, and there are some volcanoes around here. And we interviewed one of the local people, lives about a couple miles away, and he said, indeed, there are volcanoes here. So that leads us to believe this is a volcanic rock that sat around in the desert, got desert varnish. And we looked around the lab, we got some other rocks. We found this rock. It is a common rock that comes out of volcanoes. It's known as scoria. That was found in this area also. And now when you have scoria made, lava comes out of the ground and it's bubbling with gases. bubbling with gases, and the substance has holes and bubbles, and then it kind of freezes or it cools down, and those bubbles stay there. So you end up with a rock that has a lot of holes in it. And those holes, they start out as being kind of rough, not smooth. And we're in the desert, so if a rock sat in the desert around here, there's a lot of sand and there's a lot of wind. The wind will whip up the sand will bump against these things and make everything smooth, including those holes. So the process, we think, what happened was the material came out of a volcano nearby, made the rock, and it made these bubbles in it, and then sand came along and smoothed the rock and also smoothed the holes. And then as the rock sat there for years, water circulated through it and eventually made this dark deposit on the outside. So that's how we get our rock here, which looks like a meteorite. Really neat stuff here in the desert of Utah. Thank you. Okay, so what we did today was we did what scientists do, what scientists call testing a hypothesis. We started out with a mystery. We found these rocks in the desert. One hypothesis we had was they were meteorite. Okay, and another hypothesis that I came up with was they were actually limestone. And so we did a chemical test. We did the acid test for calcium carbonate. Calcium carbonate is in limestone. Now calcium carbonate is the name of the chemical, limestone is the name of the rock. Now sometimes people also say that this is the mineral calcite. So you have all these names, they mean about the same. Calcite is the name of the mineral, calcium carbonate is the name of the compound, chemical compound, and these are found in the common rock of limestone. So when we add the acid, there should have been bubbling. There wasn't, so we were able to say this definitely was not limestone. Okay, and in the end, we concluded after research and talking to people that what we had was a volcano nearby, volcano just a couple miles away, and it erupted and formed a rock called scoria, which makes a lot of holes in it. And then the scoria was acted upon by desert varnish. And so we end up with a rock which is just like we found. And we did this by using testing a hypothesis. Thank you.